So in here, it's asking us how many pieces can we fit in, or circles can we fit in, if the area of the circle is 7.1. So first we gotta figure out the size of the circle. So like area of a circle equals pi r squared. And we have 7.1, which equals pi r squared, and we can divide both sides by pi. I'm going to pop that into the calculator really quick. 7.1 divided by 3.14. This is going to give us, and I'm going to do some rounding here, 2.26 equals r squared. And then I want to isolate that. So r will equal the square root of 2.26. So once again, I'm going to put that in the calculator, and that gives me r equals approximately 1.5, which will give me a diameter, or a circle size, of 3 inches. So a circle with 3-inch diameter after rounding. So that's the first thing we got to do. We got to figure out what the circle size is. So that's a little bit of a step. Now, people wrongly figure this out, where they would take that, the area of my sheet, which is base times height, and 8.5 times 11 would give me 93, an area of 93.5, and they'd be like, well, we'll just divide this by 7.1, and that means it could fit 13.1 circles. That is not correct, because that is how much area there's available for the circles, but that many circles won't actually fit at 3 inches. You got to actually do some other calculating. So keep this in mind. Your circle here has a diameter of 3. So I'm just going to erase all this, and then I'm actually going to take us into Fusion 360, and we'll do this a little bit of a more practical way. Because I often get like people say, well, 13, and that is not correct. So I'm just going to write up here, diameter of the circle is 3 inches to remember, and I'm going to take us into Fusion 360. So opening up Fusion 360, I have my area. It should be 8.5, and I need to put 3-inch circles in here. So I'm going to draw a circle with a diameter of 3 inches, and I need to figure out how many of these will actually fit in this area. So if I put this up in the corner like that, right in the corner, and then I want to do a copy of this. So let's see if I can make this happen. Copy, and I'm going to paste it, and we're just going to move this here. I'll do it again. Enter. Paste it again. I can get 1, 2, 3, and then maybe if I move this out to the corner here, and I move this kind of centered, and then maybe I make another one. Let's go right to the bottom. Make the same kind of thing there at the bottom. So that's 6. And then I can even, if I'm careful, squeeze some out in the middle. Now I've been through this and I've played with this a lot more. This is the maximum amount of circles I can get onto this size sheet here. So this is 1, 2, 3, 4, 5, 6, 7, 8. You could have done this a lot of ways at home. You could have played with it any number of ways. But when it comes down to it, you are not going to get more than 8 circles in this area. So that is the answer. It is 8 circles. All right, so now that we've established that we have 8 circles here, we have to start running through what to do with them. Let's shrink this up. Okay, so we have 8 circles with an area. 8 circles with an area of 7.1 each. So we've got to multiply that. So the circle area equals 8 times 7.1. So we've got 56.8. So that is the area of the circles. And I'll just move that back up there. So 56.8. So we need to take the total area of this piece of paper. So the total area is base times height. Area equals 8.5 times 11. Area equals 8.5 times 11. Area equals 93.5. So we have to take this area and subtract out this area. So 93.5 minus 56.8. So minus 56.8 is going to give us 36.7 inches squared. So that is the area of the remaining paper, which is the waste. So that is the waste area. What percentage is this waste? The percentage, so to percent waste would be to take our 36.7 and divide it by our total area and then multiply by 100, and that will give you the percent waste. So 36.7 divided by 93.5 equals that number times 100, just over 39% waste. So 39 point, we'll say 3% waste. So that is the answer for the waste section. All right. And after another costume change, I will be doing the next section. Number 7. Okay, so number 7, we have an ellipse with an area of 4.71. Its minor axis is 2 inches long. Solve for the major axis and then sketch it. Okay, so area for the ellipse here is pi times half of A, and then times half of B. And when we're looking at this, A being the major axis and B being the minor axis. So when we continue writing out our formula here, we have an area of 4.71 inches squared equals 3.14 times 0.5a times 0.5 times 2, which is obviously going to be 1. So this can actually go away. So that goes away because it's going to be 1, and anything times itself is going to be 1. So the whole of b is going to go away. That's really easy. It makes your life easier when you're doing these calculations. So now we're going to have 0.471 inches squared equals 3.14 times 0.5 times a times 1, because that's what b is. So this doesn't matter. This goes away. So 3.14 is going to need to get moved over to the other side. So divide by 3.14 inches. These will cancel out, which is going to isolate my 0.5a is going to be equal to 4.71 divided by 3.14, or pi, which is going to give us 1.5. Now to figure out a, you would obviously divide both sides by 0.5, which is going to give us an a of 3, because 1.5 divided by that half is 3 equals a. Okay, so the length of a is 3. And since each grid space here is going to be 0.25, that means that it's going to be 1.5 inches in each direction. So take a quick pause to look at the math here. I'm going to erase it to draw my axes. So to finish my drawing here, since that is a, I already have the 2 in, 1, 2, 3, 4. So I gotta get to 1.5, 1, 2, 3, 4, 5, 6. So right here it's going to be halfway, 1, 2, 3, 4, 5, 6. It's right here, and then I'm going to do my best to approximate the ellipse, which I am doing an awful job. Awful. But you do your best. So we're gonna end up with 3 inches from here to here. And then we're going to end up with 2 inches from here to here. And I feel like that's a good place to stop for this on number 7.